Okay, in question 2, a lot of you are throwing away a lot of easy marks just because you're not reading what the question's asking you to do. So here's some data: internal assessment mark on the x-axis, exam mark on the y-axis. Maybe they're trying to hint at some sort of correlation between the two, but let's have a look. So this is the bit that a lot of you are doing wrong. On graph paper, fine. Trace graph, yeah. This is it. Use a scale of 1 centimetre to represent 2 marks. So you need to be using a ruler, and on the x-axis, every time you measure 1 centimetre, 2 marks. Another centimetre, another 2 marks. Another centimetre, another 2 marks. Okay? So loads of you lost a mark because your scale was just wrong. And on the y-axis, 1 centimetre is 10 marks. So 1 centimetre, 10. Measure another centimetre, 20. Okay? And the examiner will have a graph that's drawn to scale, and yours should look exactly the same. If it's not, then your scale's wrong. So on our graph paper, one of the big squares is 2 centimetres. So you need to be doing half of a big square. I'm not going to draw it out because that would take too long. I will just place on here one of Desmos, and I'll just talk you through what the marks were for. So you had to, out of the 3 marks, only one of the marks was for getting the dots in the right place. So 1 mark for getting the dots in the right place. The other marks came from the scale. So you had to make sure, like I just said, this should be 1 centimetre, this should be 1 centimetre. And the other mark came for labelling the axes. So this axis Y, this one X, and saying what they represented. So the x-axis would be internal assessment marks, etc. And this axis would be the examination marks. So 3 marks you definitely all should have got, and more than half of you didn't. So fix it, please. For part B, again, easy marks if you know how to use your calculator properly. A lot of you don't. Write down the Pearson's product moment correlation coefficient. So this is the R value, and it's going to tell us about the strength of the correlation between the 2 variables. You need to know how to do it on your calculator. Those of you that did it on your IA will know that it's a bit of a beast to do by hand. So if you insert a table, title them X and Y, just remember which one's which, put your data in pairs, click on one of the blank boxes, and then go to Menu, Statistics, Stats Calculations, and go to Linear Regression. So linear regression is telling us the kind of line of best fit between these scatter graphs, and that's going to in turn tell us about the correlation. So where's the X list? Which one do you want on your x-axis? Or we called it X. Which one do you want on your y-axis? We called it Y. Where do you want the information to go? You can leave that as is, leave that as is. Show the results in column D. Yeah, fine. So this is the output. So here, linear regression in the form mx plus b. The value of m, we'll need this in a second, we'll come back to this. The value of m, the value of b, the value of r squared, which we're not interested in, and the value of r. The r value here, this is your Pearson's product moment correlation coefficient. So this is the number that you need to be writing down. So let's just go back here a second. Pearson's, the r value equal to 3 significant figures, it was 0.981. So just remember that process, please, because it's not tricky, you just need to know how to do it. What does this tell us about the correlation? Part B, describe the correlation. Well, we said that if you had, if the R value was 0, then there's no correlation. If the R value is -1, then there's a perfect negative correlation. And if the R value is +1, then there's a perfect positive. And anywhere in between, the strength of the correlation varies. So here, we can see that this is very, very, very close to +1. So this means that there's a very strong positive correlation. So part B was worth 2 marks, and you had to say that it was a positive correlation, but that wasn't enough because you need to comment on the strength of it. So in this case, because it's so close to 1, you want to be saying something like very strong positive correlation. For part C, you're asked to find the mean of x and the mean of y. So you added all the x's together. I won't do it now. You add all these, 4 plus 10 plus 12 plus 16 plus 18 plus 20, and divide by 6 because there's 6 bits of data, and the same for the y. So the mean value should have been, what was it, x mean? Let's write it like this. X mean was 13.3 to 3 significant figures, and the mean of y was 53.7 to 3 significant figures. So mark for each of those, and then plot it on your diagram and plot the point M on your diagram. Okay, so here you would just have to go to, where are we, 13.3. So you could just do this quite accurately, 13.3 and 53.7, somewhere around there. And it said to label it M. So you put a cross and you label it as M. Part E, write down the equation of the regression line. As soon as it uses this word regression, again, you know that's a calculator thing. And in fact, the way our calculator does it, it actually tells us the regression line before it tells us the Pearson's value. So the regression line, let's just check back on here. It says regression equation in the form mx plus b. M value is 2.13846 and the b value is 25.15. So if we give these both to 3 significant figures, then we can say that y equals 2.14, because it was 2.138 something, x plus 25.2. Okay, so this is telling us the gradient for every 1 mark you go up in your internal assessment, 2 marks up in your examination result. And this, the plus b, is the y-intercept. This is where it's crossing the axis. So we're going to plot that in a second. We'll come back to that here. For part F, use your equation to estimate the mark for a student who scored 8 on their internal. So 8 on the internal assessment, this was the x variable. So what you had to do here was substitute a in for x. So we should see y equals 2.14 times 8 plus 25.2. So on a calculator that comes out as 42.3. Because they're specific about the way in which you do it, you can't use the graph, okay? Use your equation, it says in bold, so you're using this part here. So 42.3. And last one says draw the regression line on your scatter diagram. So here's the regression line. You've got to add that to your graph. So when you're drawing a regression line, they're going to look for 2 things. Let me just add the mean point back on here, because your regression line must go through the mean. So let's just say the mean was there, I can't remember exactly. If that's the mean point, your regression line must go through that. And it also must go through, you must get the y-intercept correct. So in ours, it was y equals, what was it, 2.14x plus 25.2. This 25.2, when x is 0, y is 25.2, that's got to be in the right place. Otherwise, you're not going to get your mark there. So again, simple mark, don't throw it away. 25.2-ish here. And you're using a ruler and you're connecting that point, straight line, through the mean, straight line, etc. Okay, so please, a scatter graph question you shouldn't be losing too many marks on. The more practice you do at past papers, the more familiar with the mark schemes you'll become. Oh, final part. A new student scores 30 marks for internal assessment. Use the above data to estimate that her score, and she uses the data to estimate that her score will be 89 on the internal. State whether this estimation is reliable. Well, we've got 2 ways we can check it. We can either use the equation, y equals, what was it, 2.14x plus 25.2, or we can use our regression line and read it off the graph. So if you're going to be using the equation, you'd have to substitute, what did she get, 30 on her internal assessment, so 2.14 times 30 plus 25.2, so you would expect her to get, I think it came out as very close to 80, I don't have the calculator on me right now, I think it came out very close to 89%, you can check it. With the regression line, I don't think my line's still going to be there, that's a shame. Imagine, if you will, that the line was going something like this, 25 up through the mean and across. If she got 30, then we're all the way over here. If you read off your graph, which is way more accurate than mine, it would have brought you out at about 90. So you read up to the line, so the line must have gone a bit more like this. You read up to your line, read across, and input of 30 gave an output of 90. So when you're making a judgment about whether that's a reliable estimate, well, our equation gave us 89 and the regression gave us 90. So I would say that that's a pretty reasonable estimate, seeing as though both methods gave us close to the estimated answer. So yes, I think, well, that is a reliable estimate.